Alright, so I am not here today, obviously. I'm working off-site. So today's lesson is going to be this video, starting our new module, 5.1, multiplying polynomial expressions by monomial. So you should be on page 169. So I'll give you a second to turn there. And while you're turning there, our essential question for the day is how can you multiply polynomials by monomials? So remember, poly means many, and then monomial means one. So we're going to do some multiplying of a single term to single terms to binomials to two terms, trinomial three terms, and may even get into four-term multiplication with a monomial. So I want you to think about that question because you're going to have to answer something similar to that at the end of the lesson. So have that idea as we go through this whole lesson here. Alright, so initially we're going to model polynomial multiplication. So going back to using tiles here. And so we're going to start with simplifying the expression of 2 times x plus 1. So let's take a look at the tiles. Alright, so I already have this set up here. So you can see here that I have 2 down the left side and then x plus 1 at the top. And then this then just becomes like your multiplication chart or table you've done in elementary school, where we take the left side row and the first column and you multiply those together. So when I go 1 times x, that is going to give me an x right there. And then when we get the 1 times the 1, we get 1 there. And then we do the same thing with the bottom, so I get 1 times x, and that gives us x there. And then 1 times 1 gives us another 1. And so when we look at what's left over there, we count how much we have. So we have 2 x's and 2 1's. So then we would say that 2x plus 2 would be our answer. So let's go back and look at that here. And as you can see, as we distribute this, so we've talked about that idea before, that's where our 2x comes into play, and 2 there comes into play. Okay, so another way that we can look at this is called the area model. So here we're not going to write out the 1 separately, we just have the 2, and then across the top I have x plus 1, and you make a rectangle that fits that, and then for each plus you put a divider, and so you just multiply these. So it's 2 times x is 2x, and then 2 times 1 is 2, and so we get 2x plus 2. And that's what the tiles is modeling for us, is that area model, which is just another modeling of distribution. So let's look at our next example there. So we have 2x times x minus 3. So again, we'll look at the tiles here. As you can see, I have 2 x's on the left hand side, and then I have an x minus 3, so 3 of those negative 1's there. And so this time we're going to multiply again together, but now we have an x times an x, which if you look at that area, I'm going to have an x going vertically, but then I also have an x going horizontally, which is going to create an x squared for us. And then our x vertical times the 1 gives us one of those, but it is negative, and we get 3 of those across there. And then since it is another x multiplied across, we end up getting the same on that bottom row. And then as we count it, what is left in our multiplied area out, we have 2x squareds and then 1, 2, 3, 4, 5, 6 negative x's. So we would say it's 2x squared minus 6. So back to here, we'd have 2x squared minus 6x. So we're going to take and multiply that in. So 2 remains the same, and x times x is x squared. And we multiply in, that gives us that negative 6x. And if we did the area model, I get x minus 3 across the top. So we multiply 2x times x is 2x squared. Negative 3 times 2x is that negative 6x, which we saw already. Alright, so let's start with just multiplying monomials. So as we've done a little bit before, but just dealing with our exponents, now we have some numbers. Fairly straightforward. We deal with our numbers first. So 6 times negative 4 is negative 24. And then we multiply our x's together. And remember, when we are multiplying and the base is the same, so it looks like this, we just add our exponents. So this gives us x to the 7th. Now our next one, we have two variables, x and y. Nothing should change. We still do our numbers. So 5 times 7 is 35. X times x, there's a 1 on each of those, so that becomes x squared. And then we have y squared times y, which there's a 1 on that one, so we get y cubed. So notice that each step I am just dealing with the numbers, then my first variable, and then my second variable. If there's a third variable, we deal with that one then at that point as well. Alright, so a little reflection here. In the product of powers property, do the bases need to be the same, or can they be different? So think about the problems that we just did. Okay, so we did the product of powers, which was we added our exponents, we're multiplying. So the question is, do the bases need to be the same? So you can go and pause this video here if you need to think a little bit and reflect on this, then go ahead and write your answer down there in your book. And while we're at it, at any point is going a little too fast for you. The beauty of a video is you can pause, you can rewind, you can do all of that. So feel free to do that as you're working through this. Alright, next, multiplying a polynomial by a monomial. So now we're on page 171. And so we've done a little bit this when we did the tiles. So we're going to be distributing. And so on the first one, I'll show you distribution and area model. On the second one, I'll just do distribution, but if you want to do area model, you can do that one as well. So distribution here, again, this is like a monomial. So if we just look at that first term, it's what we just did as far as multiplying two monomials together. And that's all we're going to do as we distribute. It ends up just being a monomial times a monomial once we've distributed. So we deal with the numbers. So 3 times 3 is 9. X times x squared is x cubed. Then we distribute to our second term. So 3 times 6 is 18. X times x is x squared. Then we distribute to our last term, and that is minus 15x. Okay, now area model, we have 3x down one side, and 3x squared plus 6x minus 5. Drawing a rectangle, each plus or minus, I get a new box, and then we just multiply as we saw. That's 9x cubed, 18x squared, and then negative 15x. With just a monomial being multiplied in, area model is not all that fancy, but introducing it because later as we do binomial time a binomial or binomial times a trinomial, in bigger terms, area model can be very helpful then. Alright, so let's do the second one. So again, multiplying in, deal with the numbers. So 2 times 5 is 10. X times x squared is x cubed, and y times y is y squared. Notice even though we've added a variable and we've added multiple terms, that all we're doing is the same thing as we did on the previous. Up here, as I dealt with my numbers, I dealt with my x's, then I dealt with my y's. So we're doing the same thing. We're just going to repeat that process 3 times for this one. 2 times 3 is 6. X times x is x squared. Y times y squared is y cubed. 2 times 7 is 14. X times x is x squared. And y times y is y squared. Okay, again, if you need to process it a little bit, you can pause here. Otherwise, moving on to an application of this. So we are multiplying a polynomial by a monomial to solve a real-world problem. So we're on page 172 here now. And so the problem at hand is Harry's building a fish tank that is a rectangular prism. He wants the height of the tank to be 6 inches longer than the length and width. It needs to be the volume to be as close as possible to 3,500 inches cubed, which should be the length of the tank rounded to the nearest inch. So let's analyze first and see what we're actually given. So since the bases are square, okay, the length, our width, we now know are equal. Okay. And then the height of the tank is 6 more. So right here, the height of the tank is 6 more inches longer than the length and width. Right? And then the total volume of the model should be as close as possible to 3,500 inches cubed. And so that's given to us right here. Okay, so again, just identifying the information that we're given before we dive into filling that information out. Okay, so next we want to formulate a plan before we dive into this. So since the desired volume of the model is given, the volume formula should be used to find the answer. The volume formula for a rectangular prism is, and so we did this in semester 1, so we know that the volume of a prism is length times width times height. So we're going to use this formula and the given information from previously to write and solve an equation. So to solve, we're going to build our equation here. Since we already said that the length and width are equal, let S represent these measurements. So our length is S and our width is S. And then we know our height then is 6 more. So that would be S plus 6. That would make it 6 more than the length. And then as we simplify this down, we get S times S is S squared. And then we still have S plus 6. Then we're going to distribute. So S squared times S is S cubed. and then s squared times 6 is 6s squared. Okay, so that gives us an equation for the volume, and now we're going to do a little guess and check with that. So we have s squared and that is s cubed, and we have 6s squared there. So a little guess and check to find a volume that is around our needed 3,500 inches cubed. So what I'm going to do is I'm going to substitute 11 in. So the way that's going to work is I'm going to go 11 cubed plus 6 times 11 squared. Use your calculator, multiply that out. And then once you do that, you can get 2,057. And then same thing with the 12. We'll go 12 cubed plus 6 times 12 squared. Go and punch that into your calculator. And we get 2,592. If we do the same thing with 13, this time we get 3,211, so we're getting closer to that 3,500 that we want. So we'll try one more at 14. And that gets us to 3,920. Alright, so we didn't land exactly on our 3,500. It's probably some decimal in there. But for us, we're just kind of evaluating this, trying to get to where we can. And so we know that our closest to 3,500, based on what we saw, is the 3,211. That's a little less than 300 away from 3,500, where the 3,920 is 420 away. So since we know that, the length of the fish tank to the nearest whole inch should be 13 inches. Right, because that was a problem I asked for. I didn't ask for decimals, so we just needed 13 inches there. Hey, good. All right, your turn now. And so posted quizzes on Classroom. It is posted as a homework. It is fairly short. There are only, I believe, 3 questions as you work through that. That is due by the end of the period. Okay, and you will be graded based on effort and how well you do on it. So take that serious. And then once you have completed that quiz, you can come back and answer your essential question here. So on page 173, what properties and rules are used to multiply a multi-term polynomial by a monomial? Okay, so if you go back through the notes, I've either written it down or stated the different properties and rules that we used in order to multiply today. And then so once you finish your quiz and your essential question, you can get started on your assignment.